Welcome to the project demonstration of a novel technique of AC power control using microcontroller based inverter. So here we are developing a inverter with 50 Hz of frequency and 12 volts AC initially with the help of the microcontroller. So from there we are going to generating the AC pulses of 12 volts, and that will be step up to 230 volts with the help of this step up transformer of 1 amp. So here the input signal is directly we are producing from the battery 12 volts AC to the microcontroller section. There we use a 7805 regulator because of microcontroller will work under the 5 volts of DC only, and it will generate the 50 Hz pulses from the microcontroller to this IC. So this IC will step up that 5 volts AC which is getting from this microcontroller to 12 volts AC. So same 12 volts AC is input to this MOSFETs. So these MOSFETs will increase the current for the 12 volts AC. So from means 12 volts AC to 12 volts 1 amp AC power supply. So right. So first starting onwards, 12 volts DC input to microcontroller and parallel 12 volts DC input to this IC circuits. So the 12 volts DC to 5 volts DC after this 7805 regulator, and from there controller will generate the 5 volts AC signal that is input to this IC. So this will increase the voltage, means 5 volts AC to 12 volts of AC, but with less current, as these can generate up to 50 milliamps only. But we need to increase the current. For that purpose we are making use of the MOSFETs. How? Nothing but the on off signals will be given as input to the gates of this MOSFETs. So these MOSFETs are acting as a switch between the 12 volts DC battery and the transformer. So if this IC on, MOSFET on, and this IC off, MOSFET off, so that's 50 Hz of on-off pulses will be given to this MOSFETs. So these are on-off, nothing but same 12 volts DC is converted to 12 volts AC with 1 amp current. So when we provide that input to this transformer, so this will step up to the 12 volts AC 1 amp to 230 volts of AC voltage directly. So once we provide that to this transformer to the load, directly we can utilize that at the load section. So coming to the interfacing connections, here you are directly, there is no input to the controller to check that sensing one. Directly when we are providing that voltage, it start producing the pulses. So that was directly given as input to this IC circuit. So on this motherboard, so we can see the main component as a microcontroller PIC1672, and this is a 20 MHz crystal oscillator which will provide the clock pulse to the controller. So next is reset switch to restart the microcontroller, and the next LEDs which show the status of the power on this motherboard. So coming to the battery pack, so here we are using the battery pack of 12 volt 1 amp. Right, so we can charge a battery. So to charge a battery, just connect the B to the B slots and D to the T slots. So this is a transformer, so we need to connect the transformer over here and give the power supply to this power cable. So this transformer will step down the 230 volts AC to 12 volts of AC, and this regulated power supply board will convert the 12 volts AC to 12 volts DC, which is sufficient to charge our battery. Once the battery is charged, so it will take around of 6 to 8 hours. So once the battery charged, you can just disconnect the charging and you can switch off the transformer. So you can keep this aside. So now the system will work based on this on off switch. So when we on that, so as we described, so the initially 5 volt AC signal generated, and from there to the 12 volts AC, and from there to the 12 volts AC 1 amp. So that is the main input to this transformer, so which will step up the 12 volts AC to 230 volts AC from this step up transformer. So in this way we are going to convert the DC to 230 volts AC signal by using the microcontroller inverter.